Hi, thank you all for coming. My name is David. I'm a lead engineer for Seznam full text search. Does anyone here know Seznam? There are a few people. Seznam is a local search engine in Czech Republic, and the Czech Republic is last country in Europe where Google did not dominate the search engine market yet. And we are very proud of this, and we hope it will be there for a while. So a little bit of history. We started using Hadoop ecosystem in 2010. We still have one of the largest Hadoop deployments in Europe. It's about 1,500 machines over 2 data centers. And so basically most of our data pipelines are still written in MapReduce. So we'll go through a little bit of buzzwords. It can be imagined as something called batch architecture, which has obvious problem. If you're doing search engine and you need to get fresh results into the search, it can take weeks for the new documents to get to the index. And so something like Lambda architecture started to exist. You just had this like fresh layer, and there is obvious problem that you need to write all of your business logic twice. So there was another architecture that could solve this. It was called Kappa architecture, where you have streaming only, but it has some other disadvantages in terms of scaling, etc. So we came up with something we call Euphoria architecture, and Euphoria is the project I'm gonna talk about today. The project dates back to 2014, and its primary purpose was to unify stream and batch processing, and also many emerging technologies where in big data space there was Apache Storm, Apache Spark, Samza, etc. And we also wanted to unify, like, make it runner independent, because for us it would be really large investment to rewrite everything to Spark, and then we would hit the scaling limit and we wouldn't be able to go to move to another technology. In 2015, Dataflow paper came out. We realized we are heading the right direction. And in 2016, it was released as Apache Beam. And so we released Euphoria also, and we were contacted by Davor Bonacci, and we started thinking about merging Euphoria into Beam as a high-level DSL, so we can share all the work on runners, etc. So in 2018, we finally decided to make this investment into moving our code base to Beam, and that's what I'm going to talk about today. So what are the goals of the project? We want to provide high-level Java 8 DSL. What it means. Right now, I guess most of you are familiar with Java SDK, and right now it's more of a low level, and it doesn't allow you to do easy prototyping. You need to care about coders, etc. Who did struggle with coders here? I would say most of the people. And we allow you to don't care about types at all during prototyping phase, and if you want to move to production, you can optimize. We want to focus on describing the business logic itself, not the specific implementation. I will talk about this later. And some basic concepts, like first concept is that dataset. It's basically just a wrapped P collection with some additional metadata. And then the other concept is called operator. Operator is just a description of the data transformation you are trying to do. So, for example, if you have the the simplest one, which is map elements. You just need to give it a name, you give it an input, you give it your UDF, which will, in this case, just extract the length of the string, and you'll output this. Most of these builders have, like in Beam currently, they have this problem that they have many options, and you are never sure about all the options you need to provide. So we have this concept of builder chains. It's slightly more difficult to write these builders, but from a user perspective is much more friendly. So if we take a look at the map elements, you just start with the name. It returns an off builder, which allows you only to do another off operation. It returns using builder, which lets you to provide your UDF, and then you can do output. And it doesn't allow you to do any other steps. So it's kind of supposed to lead the programmer, so they always know what is the next step. More advanced concept are shuffle operators, is all that key by operators, joins, reduce by key, combine by key, etc. They also have options to set windowing. If you take a look at the capability metrics, in order to have really nice DSL, we do not provide all the capabilities that Beam does, but the API is fully interoperable with Beam. So if you just need those capabilities, you can always use the core SDK. So for example, Pardue, we just have flat map. We don't have concept of bundles, etc. But you can still use Beam if you need this. Group by key is the same. Flatten is called union. Combine by key is the same. We have a concept of composite operators. So most of the operators can be expanded to primitive ones, but we allow you to provide your own translation for the operators. So if you have some use case where you need to do some specific optimizations, you can provide this. We support site inputs, but not in the way the Beam does, because using site input is still a join. So we just have join, and that's usually enough. I'll talk about this later. We don't have source API and splittable UFNs. You can use the one that Beam provides. We support metrics, and the stateful processing is coming in next release. The type system. As I said, in the prototyping phase, you don't need to care about types at all. If you will try to print the type descriptor of this transformation, it will default to Java-lang object. We can sometimes infer the type from your UDF, but we don't do this because it would be inconsistent, and you would be sometimes unsure if your UDF can actually provide type or not. So for this, we need a cryo extension, so we can use it to serialize your objects, and you don't need to care about types at all. Cryo can be really ineffective if you don't register your classes, because then if it doesn't have the class register, it needs to send the whole class name with every value it tries to serialize. So we also allow you to register your classes, and we allow you to set some nice options to Creo. For example, that it will force you to provide class registrations or buffer size, etc. If you are trying to move to production and you are not happy with cryocoders, you can provide your own type descriptors, and then it works pretty much the same way you are used to from Beam. Another really nice feature is runner-independent data skew handling. For example, you're trying to, there is an example from like search engine space. You are trying to join some metadata from domains, and you're trying to join it with documents. Documents is just some URL on the domain. So the transformation would look like you have two inputs, domains and documents. You join them by domain key. You provide your joining function, and you build the operator. It's as simple as this. And now there is an exponential data skew problem, because like most of the domains are reasonably sized, but on the long tail, there are some really huge domains like YouTube, Twitter, Facebook, and probably many more, and they have hundreds of millions of pages which you need to join on a single key. So there are many implementations of join you can use. For example, broadcast has join. Who is familiar with this concept, like broadcast has join? Okay, so if you imagine like Beam SDK being a low-level API, we can translate this, like one data set that fits into memory can be translated into P collection view, and we can broadcast it to all the executors, and we can do map side join, and we are just doing in-memory lookups to the smaller side. So we don't have to shuffle the large data set over the network at all, and it will be really fast. There is an obvious problem that most of the times that small data set does not fit in memory, and then you need another implementation. So another option is that you can split the large keys. For example, if you have YouTube, you can just copy the domain key multiple times, and you can randomly distribute the data you are trying to join to those keys. So basically, it's still a join, and you just switch the implementation. We have like really huge plans with this approach. Right now, you must manually specify if you want to override the implementation, but in the future, we want to provide some way to sample the previous runs of the job and to automatically infer what implementation is best for you. So in the future, we definitely want to support stateful processing. We had this concept in like our own project, which was like predecessor to the DSL, but it's not really easy to translate it into Beam. And another thing I've talked about is like if you have operator, it's just a description of the transformation, and you just pass it to operator transform, and we do a lookup into translator registry, which you can supply through pipeline options, and we try to realize what the translator is. So you can actually like provide your own logic for choosing those translation, and if we don't have if we find the translation, we just use it. If we don't, we try to realize like if the operator is a composite one. If it is, we just expand it. If it's not, we fail. So as I said, we want some like advanced translator registry capabilities that you can leverage. And we want to do like sampling of previous runs, so we can again leverage those data in order to optimize your pipelines. And all of the work has been done as part of Beam 3900, and we are actually going to send a final pull request into Beam Master next week, and we are looking forward to this. Here are some heroes of Euphoria that like implemented this, so thanks them, and thank you for coming. And if you have any questions, just ask.
Thank you, David. Any questions?
Can you maybe give us an example how a pipeline looks in this DSL?
Okay. Okay, you can just like start out the way you were used to in Beam, because you need to use Beam IOs, and you just call dataset of P collection, and you can then use our transformations. Here is like map elements, then you can do flat map, you can do some reduce by key. This is an example of like top end selection that fits in memory, is combinable. You just use like priority queue. Let me find. Here is example of like reduce by key, count by key. We provide this like high level transforms like for counting, etc. Yeah, so this is probably the best example I can show you right now.
Yeah, thank you.
Cool. Thanks a lot, David. Let me check the time.